So the test is logarithmic test. Logarithmic test, first I'll give you the statement. Statement is let summation n 0 to 120 un be a positive term series such that limit n tends to infinity n log n is equal to L. It depends on L, like ratio and ratio and root test. So then this series, the given series, will converge if L is greater than 1, and it will diverge if L is less than 1, and test fails if L is equal to 1. Okay, so now the example that I am going to do is 1 plus 2x by 2 factorial plus 3 square x square by 3 factorial plus 4 cube x cube by 4 factorial plus 5 for x power 4 divided by 5 factorial plus dot dot dot. Now to apply these tests, first we need to find the un. So here un is equal to n power n minus 1 x power n minus 1 divided by n factorial. You can check here also that for n is equal to 1, u1 is 1. For n is equal to 2, if you check, then u2 is equal to 2 power 2 minus 1 x2 minus 1 divided by 2 factorial, that is 2 into x by 2 factorial. Similarly, you can check for other terms also. Now un plus 1 is n plus 1 power n x power n divided by n plus 1 factorial. N plus 1 factorial. Now we are finding this because normally the logarithmic test is used when we have the e exponential term. So first we'll apply the ratio test here, and if ratio test fails, then we'll apply the logarithmic test. Okay, so the limit n tends to infinity, un divided by un plus 1 is equal to limit n tends to infinity n plus 1 power n. So let's just n plus 1 power n multiplied by x power n divided by n plus 1 factorial. Now if we simplify it, then okay, there's a mistake. The mistake is that first we need to find the un divided by un plus 1 to apply the ratio test. So it will be n power n minus 1 x power n minus 1 divided by n factorial, n plus 1 factorial divided by n plus 1 n x power n. So it will be, if you multiply here, then it will be, you are left with n power n minus 1, okay, multiplied by n plus 1 from here and here, and divided by n plus 1 power n. And if you take x n minus 1, here we have x, and if you take x under the x in the denominator, then it will be x. Okay, so this is the term that we get in the un, in the ratio of un divided by un plus 1. Now if we apply the limit n tends to infinity un divided by un plus 1, then it will be limit n tends to infinity n power n minus 1 divided by n plus 1 power n plus 1 divided by x. Okay, if you simplify it further, then you can take n plus 1 and n plus 1 in the one side, and it will be n power n minus 1 divided by n plus 1 power n minus 1 n power n minus 1 divided by n plus 1 power n minus 1 into n plus 1 divided by, okay, so this form is not helpful, so one form, that is we multiply n here, so not multiply it, we can write it like that, right? N plus 1 n divided by n plus 1 divided by x. Okay, so it will be equal to limit n tends to infinity n divided by n plus 1 power n plus 1 by n 1 by x. So it will be, we can write it like that, if we take n common from numerator and denominator, then it will be 1 divided by 1 plus 1 by n, so it will be 1 plus 1 by n power, and similarly we can write it here also 1 plus 1 by n. If we take n common from numerator and denominator multiplied by 1x, this is the whole term. So if you take limit n tends to infinity, then it will be equal to this term, as these all terms are in multiplication, so we can apply limit n tends to infinity on a particular term. So this will tends to e, so it will be 1 by e, 1 by n tends to 0 as n tends to infinity, so this whole tends to 1 multiplied by 1, and there we don't have n, so it will be 1 by x. So basically the output will be 1, the output will be 1 by ex. Now according to the ratio test, okay, so we have written this because limit n tends to infinity 1 plus 1 by n power n is equal to e. Okay, now according to the ratio test, according to the D'Alembert's ratio test, the series is convergent when this L is greater than 1, that is 1 by ex is greater than 1, okay, or we can say that is ex is less than 1. The series is divergent when 1 by ex is less than 1, that is ex is greater than 1. Okay, now the ratio test also fails at L is equal to 1, that is 1 by ex is equal to 1. So we'll take this case also when ex is equal to, we'll say 1 by ex is equal to 1, which implies ex is equal to 1, that is x is equal to 1 by e. So if we have x is equal to 1 by e, then the given series will put value of x. Now we have a constant value for x, so we'll put that value in the given series. Then the given series is n power n minus 1 1 by e power n minus 1 divided by n factorial. Now we'll apply the logarithmic test here. So by logarithmic test, my logarithmic test will do limit n tends to infinity and log un divided by un plus 1. Okay, so limit n tends to infinity and log what is our un. If we see, we already have un divided by un plus 1, right? If we see, where is it? Yes, before applying the limit. So this is un divided by un plus 1. This is the series, right? So we write that down here, then we don't need to simplify further. So it will be n log n power n minus 1 divided by n plus 1 power n e multiplied by n plus 1. Okay, so now we'll simplify it and find out the answer. So n log n is n minus 1. If we have, it's not n minus 1, n power n minus 1. So we have n plus 1 in the numerator and denominator both, so we'll take the numerator 1 in the denominator. So it will be n power n minus 1 divided by n plus 1 power n plus 1, n minus 1 multiplied by e. Okay, so it will be limit n tends to infinity and log, we can write it like that. If we take if they have same power, so we can write it n by n plus 1 power n minus 1 e. Then it will be equal to limit n tends to infinity and log n 1 divided by 1 plus 1 by n, because we have if we take n common for numerator and denominator, then it will come out this power n minus 1 multiplied by e. Now if we take log inside the brackets, then it will be n. Okay, you can write that also. So it will be log e minus log 1 plus 1 by n minus 1. Okay, so we can take this forward. So it will be limit n tends to infinity and log e is equal to 1. You already know that. So log e is equal to 1 minus n minus 1 log 1 plus 1 by n, because log e is equal to 1. Okay, so it will be equal to, limit n tends to infinity and 1 minus log 1 plus x. I'll just, if I put that, then it will be n minus 1 by n minus 1 by 2 n square plus 1 by 3 n cube minus dot dot dot. Okay, why? Because log 1 plus x is equal to x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus x 5 by 5 and so on. This is the extension for the log 1 plus x. That's why I'll write down that instead of log 1 plus 1 by n, I'll write the expansion form. So it will be limit n tends to infinity and 1 minus, if you take n minus 1 inside the brackets, it will be n minus 1 it will be n minus 1 by n plus n minus 1 by 2n square minus n minus 1 by 3n cube plus dot dot dot. Okay, now if we take n inside these brackets, then it will be limit n tends to infinity n minus n, here we have n minus 1 plus n minus 1 divided 2n minus n minus 1 divided by 3n squared plus so on. So if you simplify it further, then it will be n we can cancel that out, so it will be 1 plus n minus 1 divided by, or if we simplify it further, if you separate the numerator, then it will be n divided by 2n minus 1 by 2n minus n minus 1. See, there is no need to do that because here we have greater power in the denominator. Okay, so it will eventually tends to 0. So no, that will be minus. Okay, then now this n will cut off, and finally limit n tends to infinity is 1 plus 1 by 2 minus 1 by 2n minus n minus 1 3n square plus dot dot dot. Now if you take limit n tends to infinity, these whole terms will tends to 0 because of n in the denominator that are less power in the numerator, so it will only come out 1 plus 1 by 2, that is 3 by 2, and this is greater than 1. So according to this statement of the logarithmic test, this the given, so hence according to the logarithmic test, the given series is convergent. Okay, when x is equal to 1 by e. So if we need to do the final answer, the final answer is the given series is convergent for x less than equal to 1 by e and divergent for x greater than 1 by e. Okay, that's it. This is the final answer. Okay, so thank you for watching the video.